And chapter 5 is further percentages. So in chapter 4 we looked at percentages, but just in the elementary stage, okay? Just in the elementary stage. Now, today let's take a look at percentage in deeper form, as you find them in paper 2 of Maths Igcse. Now, first of all, we make a table. We show fraction, decimal, and percentage. So any number we write in fractional form, then that same number we can designate it in terms of decimal and in terms of percentage. Okay? Designate in terms of so we say 1 all over 2, we put it in decimal, we do long division. So 1 divided by 2 in decimal is 0.5, right? And then if you want to change any number to percentage, remember you multiply that number by 100. So if I want to change this to percentage, I multiply half times 100. Half times 100. Similarly, this one. If it's already in decimal, you want to change to percentage, just multiply by 100. So half times 0.5 times 100, it will all give you 50%. 1 all over 4, if you change to decimal, you get 0.25. If you want to change to percentage, multiply this by 100, or multiply this one by 100, you get 25%. 3 over 4, if you change to decimal, you're going to get 0.75. So if you want to change to percentage, just multiply by 100. If you multiply by 100, you get 75%. 1 all over 8, if you do the long division, you're going to get 0.125. If 1 all over 4 is 0.25, 1 all over 8, which is half of 1 all over 4, will be 0.125. So 0.125, you want to change to percentage, multiply by 100, you get 12.5%. 3 over 8 will give you, if you do long division, you're going to get 0.375, right? So 0.375 to percentage, you multiply by 100, you get 37.5. 5 over 8 will give you, in long division, will give you 0.625. And if you change it to percentage, multiply by 100, you get 62.5. 7 over 8 will give you 0.875. And if you change it to percentage, you get 87.5. 1 all over 10 will give you 0.1, and to percentage will be 10%. 1 all over 5 or 2 over 10 is 0.2, and if you change it to percentage, it gives you 20%. 3 over 10 similarly will be 0.3. Anything over 10 is 0. That number. 3 over 10 will be 0.3. 4 over 10 will be 0.4. 5 over 10 will be 0.5. And if you change to percentage, you multiply by 100, you get that same number, okay? Now, 9 over 10 will be 0.9, and it gives you 90%. So that's with regards with converting numbers in fraction to decimal and to percentage. Now, let's work out some examples. Now, you say out of 100 sheep in a field, 88 are errors. 88 are errors out of 100. So if you want to find what percentage of the sheep are errors, what percentage are errors? 88 are out of 100. So you say 88 out of 100 means 88 over 100. 88 out of 100 means 88 over 100. Times, multiply by 100%. You know, to change any number to percentage, you have to multiply with 100, right? So this 100, we cancel this 100. This 100, we cancel this 100. And then we get something different. This one cancels this, we get 88%. So we can now simply say we have 88%. Is that okay? So 88% of the sheep are errors. How many percent are ram? Errors are the female sheep. Okay? How many percent are ram? Ram are the male sheep. Okay? Then you say 100 minus 88, you get 12. If you want to find the ones that are rams or that are not errors, you say, we call them rams, the male sheep. Okay, not the ram in computer. I mean the ram as an animal. We say this is 100 minus 88. The ones that you say what percentage are not errors, you say 100 minus 88. So you have to know the number of the animals that are not errors. So you say 100 minus 88, we get 12, right? So if you want the percentage, you say 12 over 100 times 100, which is 12%. That will give you 12%. 12 out of 100 will give you 12%. Is that okay? Now another question says convert the following percentage to fractions and decimals. So they've given us 27%. So if you want to convert 27% to fractions, just say 27 over 100. That's the fraction. So you just write 27. 27% means 27 over 100. So that's the fractional part. Now to change it to decimal, like I said, anything to decimal is just a 0 point that number. So if you're changing this to decimal, you say 0.27. 0.27. That gives you the decimal of that number. What of 5%? 5% is 5 over 100. If you want to put in the simplest form, 5 divided by 5, you get 1. 100 divided by 5, you get 20. So the simplest form of the fraction is 1 all over 20. You get 1 all over 20. If you want to put in decimal, you just say 5 over 100, which is 0.05, because there are two zeros here and there's only one number here. So it becomes 0.05. That gives you the decimal. Now, it's a convert 3 over 60 to percentage. 3 over 60 to percentage. So what we do, you just multiply, you say 3 over 60 times 100. Or you change to decimal first, and then you can now find, you multiply by 100. Or you go straight away, multiply by 100. So whichever way, it's fine. Now let's say 3 over 60, we want to change to decimal. We write 3 inside. The number we're dividing with, we write it outside, right? We write the number outside, 16. So 60 go, 3 divided by 60 cannot, you write 0. You put point, 0 point, cannot, right? So we add 0 here. Now say 30 divided by 16. How many times 60 can go to 30? 1 time. So you say 1. 1 times 16, we write 16. So we subtract. We're doing long division now. You subtract, you get what? 14, right? We get 14. So can 60 go here? No, cannot. So we add 0, right? 60 cannot divide 40. 40 is smaller than 16. So we add 0. But this time around, you're not putting decimal. You know, first time when we add 0 to this place, we put decimal. You don't put decimal second time. Just add 0. Say 140 divided by 16. How many times 60 can go to 140? 16 times 60, 32. 64 is 4 times. Right? 64 is 4 times. 128 is 8 times. So it can go 128. Again, the answer will be, so it goes 8 times. So you say 8 times 60 will give you 120 if we're not mistaken. And then you subtract. If you subtract 10 minus 8, you get 2. Remaining 3 here. 3 minus 2, you get 1. Right? So you have 12. 0 minus 1 minus 1 is 0. You have 12. 60 cannot go to 12. You add 0. You add 0 here. How many times 60 can go here? It becomes 7, right? So 7. 7 times 16. You say 7 times 6. 56, right? We write 6. Carry 5. 7 times 1. 7 plus 5. 12. Is it 12 or 11? 7 times 1. 7 plus 5. Right? 12, it cannot be bigger than 120. Cannot be bigger than 120. How many times can it go? 7 times 16. Quickly, 7 times 16. 16 multiplied by 7. $50 what? 100 and what? 112. Yeah, 112, right? 7 times 16. Yeah, this is 42. Yeah, it's 42. It's 4. 2 go here. Okay, you take it, you borrow 4, you add here, you become 11. Now 120 minus 112, we get 8, right? So 8, you add 0 again, become 80. 80 divided by 16, we get 5, right? We get 5. 5 times 60, we get 80. So this is the end of it. Once you get same number, that's the end of it. So if you subtract, you get 0. Yeah. So the number on top is your decimal. So once you get this decimal, easy to change 0.1875. Yeah. So to change it to percentage, just multiply by 100. So you say multiply by 100. multiply by 100. So if you multiply this by 100, you get 80 point. You move this decimal twice to the right. 1, 2. That's the meaning. You don't need to press calculator. You say 80.75. So your percentage will be 80.75 if you're changing 3 over 60 to percentage. So what we have done, we succeeded in changing it to decimal, at the same time changing it to percentage. Is that okay? So we move on quickly. Here are some questions for you to practice. You pause this video, like, share, and subscribe, and solve these questions. Okay? So make sure you solve all the questions here before you move on to the next. Now let's take a look at calculating a percentage of a quantity. How do you calculate a percentage of a quantity? Let's say we give you, this one is like a ratio. It will give you 300 let's say 300 ringgit or $300. We say find 25% of $300. So what you do, you say 25% means 25 over 100. Anything percent means over 100. So you say 25 over 100 times 300. Times 300. So how many times can 100 go into 300? This 20 cancel this 20. Right? So you have 25 times 3, which is 75. Right? So you get 75. So 25% of $300 will be $75. Will be $75. Right? Okay, so that's that for that. 35% of 280 is same thing. So is either you change to decimal. If you want to change it to decimal, you say 35 over 100, which gives you 0.35. 0.35 times 280. 0.35 multiplied by 280. You get the answer straight away. Or you do as we did just now. This over 100 times 280. Whichever way you follow, either you change it to decimal or you just do it in fractional form, you get the answer straight away. You get 98. You get 98. Is that okay? So here we have a lot of questions of same similitude for you to calculate. Okay, you pause the video and go through these questions. Pause the video and go through all these questions and try as much as possible to solve all of them. Is that okay? See, you have question 1 to 5 here, and then question 6 to 8. So there are 8 questions altogether. Now let's go to the next one, which says expressing one quantity as a percentage of another quantity. One quantity as a percentage of another quantity. So to express one quantity as a percentage of another, the first thing we do is to write the first quantity as a fraction of the second one, and then we multiply by 100. Okay? Like in the exam, this is how teachers they collate your marks and give you your grade. Let's say you scored 92 out of 100, they will now find percentage of that score. Or you scored 69 out of 75 questions. You got 69 questions correct out of 75. If you want to know your grade or your grade in percentage, you say 69 over 75 times 100. Is that okay? You say in an examination, a girl has 69 marks out of 75. Express this as a result of a percentage. So one quantity, the mark she scored. Another quantity is the total marks that we are giving, the total marks that are given in the exam paper. So to get the percentage of what she scored, you say what she got over the total times 100, you get 92%. You get 92%. Is that okay? So here we have tons of questions. We've put for you what you got over 50, 24 over 50 times 100, you get percentage for this one. 24, let's do this first one. 24 over 50, 24, all over 50 times 100. Times 100. Then let's see how many percentages will be. This person will not pass. If pass mark is 50 marks. 50 divided by 100. 50 divided by 50, you get 1. 100 divided by 50, you get 2. 2 times 24, you get 48. So this student would have scored 48. If assuming this was an exam, you would have scored 48%. And that's not a pass mark if pass mark is 50%. In Cambridge, most times it's 60. To get a C, you have to score up to 60. So this student failed this exam. If you get 24 questions correct out of 50 questions, or you got 24 marks out of total of 50 marks. If you get 24 marks, that means you failed that exam. Is that okay? So this is what it is. This is how we do what we do. So you pause the video and solve this question. Now let's go to percentage increase and decrease. This is very important, especially this is where Cambridge question comes out from most of the time. Okay, so you have to pay. So when we say percentage increase, we say original percentage is 100. When they say something, you buy something and there's a 8% increase, original percent is 100. The selling price of a product, the original percent is 100. Now, if they say there's an increase of that product by 8%, now the selling price will be 108%. 108% if there's increase. If there's a decrease, it will be 92%. You will minus 8 from 100 if it's a decrease. If for decrease, it will be 92% for decrease. You say 100 minus 8, you get 92%. And then you use 92 to multiply the total quantity they ask you to do. Now let's take a look at an example. A shop assistant has a salary of $60,000 per year. $60,000 per year. If the salary increases by 8%, calculate the amount extra he receives each year. So how much extra she will get each year, and his new annual salary. So what we do, you can just say, there are two ways to do it. You can say 8% times the 60,000, you know how much she gets as the increment, right? The first question is the amount extra she gets. So if you want to find the extra she gets, you use that percentage, 8%. You know they've given us 8%, right? So you say 8% multiplied by $60,000, and then we will get $1,200. We'll get $1,200, right? We'll get $1,280 to be precise. So this is what she will get. 8% means 8 over 100. 8 over 100 means 0.08. 0.08. Multiplied by 60,000. You will get what? $1,280. So this is the extra money that has been added to his yearly amount. Now, if you add this amount, you will get what? 70,280. So the new salary will be old salary plus the increase. This is the increase. Okay? Then you will get what? 70,280. But if you want the increase straight away, you now say old salary was what? 100%. You say 100% is 60,000. Another way to do it. 100% is what? 60,000. 100% is 60,000. 108% will be what? We don't know. 108% will be what? We can call it Y or X. Will be Y. So we cross multiply. This one, to make it easier, let's change it to multiplier. 100% means 100 divided by 100, which is 1. So you are technically say 1 equals to 60,000. We are technically say 1 equal to 60,000. What do we mean by that? We change to multiplier. To change anything to multiplier is to divide it by 100. So 108, if you change it to multiplier, it will be 1.08. 1.08 is equal to Y. We don't know what it is. We don't know the amount. So we cross multiply. Y times 1. Cross means the bottom here multiplied by the top on this side. So Y times 1, we get Y. And 60,000 times 1.08. You get 70,000. 60,000 times 1.0, you get 70,280. You get 70,280. Right? So this is a faster way of getting the amount. This is faster way in Cambridge. Because this is the question they normally bring. Okay? Okay, now a garage increases the price of a truck by 12%. The original price is 100%. They've increased it by 12%. If the original price was 40,500, calculate the new price. Okay, this is what you do. 100%, when it was 100%, that's the original price. So you always do that. 100%, if you change to multiplier, is what? Is 1, right? So let's just write 1 straight away. So you say 100% is equal to 1, because when you're changing to multiplier, you go to divide by 100. So 1 is equal to, what was the original price? You say a garage increases the price of a truck by 12%. If the original price was 40,500, so I write 40,000, this is the original price, which is 100%. Original price is always the 100%, okay? Which is 40,500. Calculate the new price. New price is the price that comes with the increment of 12%. The new price is the price that comes with the increment. Since this is percentage increase, we're going to add this to 100. It will become 112. So 112, if we change to multiplier, 112%, if we change to multiplier, please pay attention, this is very important. This is where Cambridge bring their exam. So if you change to multiplier, it becomes what? It becomes 1.12. It becomes 1.12. So you say 1.12 equal to what? They ask you what's the new price. You don't know. You can call it Y or you call it X. You call it anything you like. So we cross multiply. The next is so we're going to multiply this and this one now, like a 4 equation thing. So you say Y times 1. We're going to multiply Y by 1. Y times 1. Y times 1, what do we get? You get Y, right? So is equal to 1.12 times 40,500. 1.12 times 40,500. That will give us 60,240. 60,240 dollar. Okay, you must always put the currency they put. So dollar. This is how much the new price of the truck in the garage will cost. This is the new price. Is that okay? Okay. So this is how to use. If they say decrease, we would have used 112. We would have say 100 minus 12. It would have be 88% equal to Y. If it was decrease, percentage decrease. Now let's go to the third question. A shop is having a sale. It says a set of tools costing $130 at 50% discount. Now 50% discount means 50% reduction, right? So this is a percentage decrease. This is a decrease. It sells a set of tools costing this one. This is the original cost at 50% discount. Calculate the sale price of the tool. Now you say 100%. First, you must always write the 100% price. 100% price. If we change to multiplier straight away, so to save space and time, is equal to 1. And is equal to what? How much? $130. That's the original price. $130 of the items. Now they're doing discount. Discount means decrease. Discount means they are giving you a reduced price. They're selling for you at a reduced price, 50% reduction. So what you do, you say 100 minus 15. So 100 minus 50 will give us what? 85, right? So we say 85 here. Please don't, like, how did we get 85? We got 85 by say 100 minus 50% discount. So you get 85%. And if you change to multiplier, it means divide by 100, you get 0.85. So I write straight away equal to 0.85. And it's equal to the new price, the sales price we don't know. This one we use anytime we go for shopping in the mall. We use this technique. If you're good with mathematics, you'll be able to calculate even before the sales person tells you your price. So you say Y, you cross multiply. Y times 1, you get Y. 0.85 times 130 is going to be, the money will be smaller than $130. You get 110.50 cents. 110.50 cents. Okay, so this is the money you now pay. Originally, you were supposed to pay $130. That's the amount you're supposed to pay, $130. But because they're doing sales, you're able to get that goods for $110.50. That's cool, kind of cool. Okay, because they gave you 50%. If they give you 30%, will be way less than this, what you would pay. Maybe probably less than $100, what you would have paid. Okay, so this is how we apply percentage increase and decrease, and this is the part Cambridge we coerce with, they normally coerce this one with ratios and percentages and ratio of this nature. They coerce them together in one question. Okay, and it's usually very long and it carries a lot of marks. So at this juncture, you pause the video here and solve all these questions. Solve all. Don't let anyone unturned. Solve all. Okay, now we go to reverse percentage. I think the reverse one will be like almost the last one. The reverse percentage is the last one for this chapter. Let's take a look at reverse percentage. How do we use reverse percentage? This helps us to know how we did in exam. Okay, we work from the answer to the question. That's why they call it reverse percentage. Just now we were working from question to answer. Here it's like they gave you the answer. They want you to tell, if, for example, if they say I scored 92% in an exam that has 25 questions, I got 92% in the exam, they will ask me how many questions did, they ask you how many questions did you answer right for you to have scored 92% out of 25 questions. So here they give you the answer, the percentage, the answer as 92%, but they ask you, oh, how many questions did the guy answer correctly? Or probably something like that. So you're working backward. It's called reverse percentage. So let's take a look at an example. He said in a test, Ahmed answered 92% of the questions. Okay, he answered 92% of the questions correctly. If he answered 23 questions correctly, he answered 23. How many did he get wrong? You see, how many did Ahmed get wrong? If he has answered 93 correctly. So 93 represent the 92%. 23 questions, sorry. 23 questions he answered correctly represent the 92% he got, right? It's because he answered 23 questions correctly. That's why I got 92%. So you do something like ratio proportion thing. So you write 92% was as a result of the fact that he was able to answer. Okay, let's put it in multiplier, right? So we can put it in multiplier. We say 92% means 0.92 if you put it in multiplier. Okay, this 0.92 is actually as a result of the fact that he did 23 questions correctly. He did 23 questions correctly. So 92%. Okay, what will 1% be? This is like unitary formula. You know, unitary in ratio or in ratio, okay, or in proportion. So 92% is 23. 1% will be what? 1%. For this question, even if you don't convert to decimal, it's fine. 1% will be what? You say 23 divided by 92. 23. What is on your right divided by what is on your left. So 1%, if 92% is 23, 1% will be 23 divided by 92. It kind of makes sense if you check it. It gives you 0 point something, something, something. Okay? Then 100%, remember 100% is the whole questions in the exam. 100% will be what? All the number of questions that we are given in the exam. So we want to find the total number of questions in the exam which represent the 100% if you got 92% correct. So this will be 100% will be whatever you have here times 100. You say 23 over 92 times 100. 23 over 92 times 100. Cambridge also love this type of questions. They bring reverse percentage questions. Okay? And because this is also entwined in ratio. It's entwined in ratio using the unitary method. That's why they're so much interested. So if you do this, if you press your calculator, this will give you 25. Meaning the exam paper carried 25 marks. And the Yungu guy was able to get 23 correctly. That's why it's called 92%. He's a brilliant guy. Super good. A star. He got a star. He's super brilliant. Okay? So that's it. Meaning he got 2 questions wrong. Because they asked you how many questions did you get wrong. Because if you got 23 correct out of 25 questions, how many did you get wrong? You say 25 minus 23. So wrong questions, what you got wrong will be 25 minus 23, which leads, assuming all questions carries equal marks, which leads to 2 questions that he got wrong. Okay, that's for that question. And let's take a look at another question of reverse percentage. Another questions that involve reverse percentage. A boat is sold for $50,360. This represents a profit of 28% to the seller. So the seller got 28% from this deal. If he has sold the boat for $50,360, it represents a profit for the seller 28%. What did the boat originally cost? What did the boat originally cost? What is the original price? Right? So a boat is sold for this amount, $50,360, and it represents 28% of the price. So you have to add this 28. Since it represents 28% of profit, So to get the original price, you have to have this profit percentage to the original price. So to the original percentage, because the original percentage, which is the 100%, was the cost price, or the cost price without the markup profit. So to get this one, it means he added 28% so that I can make profit. This one is without profit. 100% is without profit. But when he added 28%, is with profit. And that's what this money represents. So I'm going to say 128. If you add 28 plus 100, you get 128. So 128% represent this amount. Represent this amount of dollars, $50,360. So you see where the logic is? Little logic here and there. Why? How did we know that this one has to involve you add because they say it represents the profit. This amount represents a profit of 28%. So for profit to be made, remember, selling price is equals to cost price plus profit or plus markup. Okay, you can use the word markup or you say plus profit. Okay, plus profit. So for us to get the selling price, you have to add the percentage profit to the cost price. Cost price is the 100%. The profit percentage, the cost price is the 100%. The profit percentage is 28. So to get the selling price percentage, you must add. That's how we got this 128. And the 128 represent the selling price. This is the price he sold it that gave him a profit of 28. So we say this represents this. Then 1% will represent what? 1% will represent, you say this divided by this. You say 50,360 divided by 28. So 100% will be what? Now you do for 100%, which is this cost price. 100% will be what? 100% will be this times 100. 50,360 over 128, right? Over 128 times 100. Over 128 times 100 times 100. So that will lead us to what? 12,000, right? So this will give us 12,000, meaning the cost price of the car or of the whatever they were selling, a boat, was $12,000. But he eventually sold it for $50,380. That's why he made a profit of 28%. This is the cost price, and this is the selling price. And that's, if you want to know how much he made in profit, you say 50,300 minus 12,000. That would be 3,360. Profit will be 3,000. You just subtract, okay? 3,360. That will be the profit he made, and that represented 28%. Okay. So with this, we've come to the end of today's class. Pause the video, go through, solve these questions, and thank you for joining us.